The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. Broadcast is now starting. All attendees are in listen-only mode.
Hello, good evening everyone. I'm audible. Hello, good evening everyone. I'm audible. Yes, what were we discussing in the last class, everyone? Yes, good evening Aditi, Shrikant. Yes, good evening Harshit, Jaysurya. Yeah, Mitra, I have uploaded Mitra. Happy New Year, Shrikant. Happy New Year to everyone. Mitra, I have uploaded 31st recording. I have uploaded. You can check it. Since yesterday was holiday, I couldn't do it, but I have done. Okay, you can check it once. Yes, Gagan, Happy New Year. Happy New Year, Lakshmi. How to see the recording? It's available in LMS. In LMS, you have the recordings available. You are registered under the Embedded System Internship course. Under this course, you are having the recordings. Okay, here you are having C recordings followed by you are having the the remaining recordings. Yes, so everyone, what were we discussing in the last class? See, in between the classes, you're asking me about test, you're asking me about project. I already told you, you have any queries regarding project or test, you post in a discussion forum. You have any queries regarding project, regarding when project will start, okay, that all things you have, you just post in a discussion forum. About test also, you please post in a discussion forum. Okay, Pallavi? Gagan, just now I showed you, right? You have recorded sessions here. You just click on them, you can watch the recorded session. Click open, you can watch the recorded session. They are in the LMS. In LMS, you have recorded session. You can just click on them and open it. Yeah, you'll be having a link in the mail. How to access the LMS. Did you not take test yesterday, Gagan? There was a test scheduled. Yes, everyone, did you take your test in the LMS? Yeah, same like that. You will get link. You can go and check your mail, Gagan. Chat option not okay, Nayak. It is in the okay question options only where you can post your questions. Nehanjali, you can post your questions in the questions itself. No chat option. Okay, fine. So everything apart. Okay, let us proceed further. Okay, any questions regarding test and project? You can post in a discussion forum. Let us okay, proceed with the classes. So in the last class, we were discussing about CLCD, if I'm not wrong. I told you where CLCD is used, what are the different variants of LCD like GLCD, and what variants of CLCD we are getting. Then we discussed, okay, 16 pins of the CLCD, what is the work of each pin. Then CLCD can be interfaced in two ways, 8-bit mode and 4-bit mode. When less number of pins are there, we can go with 4-bit mode. Yeah, these all things we have discussed in the last class. This is done in the last class, everyone. No, Shrikant, SPI, I2C and CAN will be not covered in the internship. If you want to learn protocols, you should join the course. Here only the whatever is required for internship means as a part of project, what peripherals are required, only that programming will be taught. Okay, fine. So everyone, yeah, this much we have done. Okay, then what we saw was from the schematic, we try to understand to which port CLCD was connected. So from the schematic to which port our CLCD was connected to, yeah, from the schematic we found out, okay, CLCD is connected to which port? Yeah. So we'll proceed further. So what is happening here? CLCD is connecting to port D and CLCD is connecting to port E as well. Okay. So your D0 to D7 connecting to port D and enable and R bar W pin, so enable and RS pin is connecting to port E. So what we have to do is we have to configure them both as output. In order to configure both as output, I have to assign tris D with 0, 0, tris E2 as 1, tris E1 as 1. For what purpose? To configure port D as output. Okay, this one. Then this is to configure RE1 and RE2 as output. Okay, these are the data direction registers. Then next, what is the step? Okay, so we have to refer the data sheet of the CLCD and we have to initialize. Okay, we have to initialize CLCD for 8-bit mode or either 8-bit mode or a 4-bit mode. Any mode we have to choose. And I already told you we have to go with the 4-bit mode because we are going to use matrix keypad here. Matrix keypad is going to share the port with the CLCD. Okay, matrix keypad is going to share the port with the CLCD. So in 4 bits of the port D will be used for matrix keypad, remaining 4 bits will be used by CLCD. So we'll go with CLCD in the 4-bit mode. Okay, so we are going to configure it as a 4-bit mode. We have to refer the data sheet. After doing this, we have to write a function to send to send a byte from microcontroller to CLCD. After using this function, what we have to do is again write a function to display a character on the CLCD and string on the CLCD. So next thing is to refer the data sheet. Okay, so we'll refer the data sheet of the CLCD. So in the material, whatever I have shared, let me show you one more time in the LMS. In the LMS, we are sharing here, you can see, apart from class notes, we are having data sheet, board schematic, template codes. You can refer code from here or individual codes are also there. Digital keypad we are not using. Matrix keypad code is there. Timer 2 code is there. Okay, CLCD code is there. Buzzer and fan code also is there. Okay, so you can use any of the codes. Okay, you can, if you anytime you want, you can have these codes. Okay, now for now, from the data sheet folder, I am going to open the data sheet for the CLCD. Okay, I'll just open the data sheet folder. Yeah, in the data sheet folder, we have here, this data sheet is for PIC controller. Okay, we have here one more data sheet called HD44780. This talks about CLCD. This data sheet talks about the CLCD. So I'm opening data sheet of the CLCD. Yeah, so here we have to follow some instructions to configure either CLCD in 8-bit mode or a 4-bit mode. So for that, here we have a flow chart. Initialization by instruction. Initialization by instruction. Okay, so what we are having here, two flow charts are there. 8-bit mode flow chart is there. 4-bit mode flow chart is there. Can you open this data sheet? Open it. I'll give you 2 minutes of time. Open this data sheet. Shrikant, we are not using I2C here. We are directly interfacing. We are directly interfacing. Yes, done, Mitra? Fine. Yes, everyone, did you open the data sheet? If opened, fine. If not, also I will be explaining. You can just watch it. So here we have this flow chart and we have to follow these steps. We have the flow chart and we have to follow these steps here. Okay. So what is the steps means? Okay. First we have to just turn on the CLCD and provide a delay. After that, what is okay mentioned here means just turn on the CLCD, wait for certain time. After that, we have to follow some sequence to okay start set it up. Just we are starting it up. Okay, these are the three sequences we are going to send. Okay, to just to tell that wake up like that something. Okay, send and make it okay ready for the communication. Okay, means to send the data. So first, what they are going to send is you can see here DB7 to DB4, what is the value? 0x03. Okay, 3, this is 3, this is also 3, this is also 3. So first RS is 0 means it is an instruction, R bar W is a 0 means it's a write. So what we have to do is from microcontroller to the CLCD, you have to write okay 3 as instruction. We have to send 3 as instruction first, then wait for 4.1 milliseconds, then send 3, then wait for 100 microseconds, then again send 3. Okay, see these are nothing but what? These are data lines, right? So you are sending. After that again send 2. Okay, again send what? 2. After 3, 3, 3, then send 2. After sending 2, next is what? Okay, some things are different here. Okay, okay, like function set, okay, display off, clear display and entry mode. So these things we have to follow here. So let me tell you what is this okay function set. Okay, what is this function set? Yeah, here we have function set in that. Okay, these are the bits DB0 to DB7, 8 byte of data, sorry, 1 byte of data, 8 bits. Okay, here X star means don't care, it can be anything 0 or 1. I'll take it as 0. Then we have 3 bits as DL, N and F. Okay, what is this DL, N and F? Okay, DL is nothing but okay stands for the data length, whether you want to send a 8-bit data or 4-bit data. Okay, so we are going to okay communicate in 4-bit mode. So for us, DL should be 0. It will be what? 0. DL is 0. Okay, 8-bit when DL is 1, 4-bit when DL is 0. Then N for number of display lines, F for character font. Okay, you can see here how many lines you want. 1 line display you want, 2 line display you want. Okay, however, you go for 4 lines here. Okay, so if N is 1 means 2 lines, it will work for 4 lines also. Then after that character font, this will decide the size of the character. See, you can see size of the character is mentioned in 5 cross 8 font, 5 cross 10 font. You can go with any one. Okay, so we'll go with 5 into 8 because we need more number of lines here. So the size should be small. If the size is bigger, you can see if you're going with 5 into 10 dots, then only one line is possible because the size will be bigger. If you go for 2 lines, then by default it will be 5 into 8 dots only. 5 into 8 dots because smaller font is required when you go for more number of lines. Okay, so that we can set here. So coming back to the function set. where it is here. So dear 4-bit mode, number of display lines, okay, put it as 1, means 2 lines, actually we'll go for 4 lines here. Okay, then font, okay, here F stands for font size, 5 cross 8 is the font size. Okay, that also here it will be 0. So here nothing will, this is 1, this is 0, this is 0. So what is your function set here? 0 cross hexadecimal value 28, hexadecimal value 28. Okay, so it means from microcontroller to CLCD as a function set, we have to send 28 to set the function, to set the 4-bit mode configuration. 4-bit mode configuration, select the font size at 5 cross 8 and 4 display lines. For that, we have to set this function set. After that, you can see for clear display, we are having these lines. Okay, we have to send it as what? 0x01 for the, okay, clear display line. You can see this is your 8-bit data, that is 0x01. RS means instruction. RW means you are transmitting. Read or write, write. So you have to send 0x01 as instruction, okay, to the microcontroller to clear a display, to clear the display. Then display on off is here. DCB stands for display on and off, cursor on and off, blink on and off. Whether you want to blink a cursor, whether you want to turn on the cursor, whether you want to turn on the display and all. Okay, so as of now, just take it cursor also off, blink also off, just turn on the display. What will be your value? 0x 0c to just turn on the display. These things you can change as per our requirements. Okay, so these are the, okay, steps which we have to follow now. Where is that? Initialization by instruction, yeah. So as a part of initialization, what we have to do here is send a startup sequence as 333. After that, okay, send a 2. Then send a function set as 0 cross 28. Okay, then clear, okay, turn on the display, okay, 0x0c. Then clear the display 0x01. Okay, so this will be nothing but the startup sequence which we have to follow now. So once you do this, your CLCD will be ready for displaying anything. You have to initially do this, then your CLCD will be ready to do, okay, ready to accept the data and display it. Now your CLCD is all ready. Okay, you can send your data now. Okay. Now when you are doing this, this startup sequence, we have to send, right, 333. For that we have to take one separate function. For that we are going to take one separate function. Okay, so here we have my microcontroller, here we have CLCD. As we discussed, we are going to work in 4-bit mode, D4 to D7. Okay, as we have discussed, first part is to configure the pins. Once you configure a pins, okay, 1 minute. Okay, first here configure the pins. Yeah. So what we'll do first, we'll configure the pins. We discussed how to do it. Next is what, as we have to follow the data sheet, follow the flow chart. But in the flow chart, what they are telling is we have to send the data from microcontroller to CLCD. We have to send our data from microcontroller to CLCD as instructions. Some instructions are there. We have to send what? First they are sending 3. Okay, then again send 3. Again send 3 with certain delay. Then send function set. Then set. Okay, then send okay display on. Okay, then cursor of this is what is that, clear display. Some initial steps we have to follow as per the flowchart. So in order to do this, I have to create one function for this. We have to send, right, every time data. So one function we are going to create, that is nothing but CLCD write. CLCD write. For this function, what we will be doing means we will be sending byte as an argument which you want to send. Then we have to specify whether that byte is a data or an instruction. So that is nothing but mode. Okay, from microcontroller, we are going to send anything to CLCD means we have to specify whether it is a data or instruction. Okay, how we are going to specify that? We have one pin called what? RS pin. We have one pin called what? RS pin. Remember? Here we discussed. Yeah, RS pin is 1 means you are sending a data. RS pin is 0 means you are sending a instruction. Yeah, whenever you are sending any byte of information from microcontroller to CLCD, we have to specify whether you are sending a data or whether you are sending a instruction. Okay, to do that, so what we will use, we will create a function called CLCD write. We'll use a function called CLCD write, where we will be sending that byte. Okay, we will be sending that byte and we have to specify the mode also, whether you're sending a data or instruction. Okay, now here mode I have to specify it to RS pin. RS pin is equal to mode, whether you're sending a data or instruction. Then next what is happening, you have to send a data. You have to send the data if it is in 4-bit mode. How to send the data? If it's a 4-bit mode, we have to send the data byte by byte or nibble by nibble. If I want to send the data in 4-bit mode, should I send my data byte by byte or nibble by nibble? How it is possible? If it's 4-bit mode, should I send my data nibble by nibble or byte by byte? Everyone? Nibble by nibble or byte by byte? If it's 8-bit mode, I can send byte by byte because 8 pins are there. Okay, 4-bit mode means only 4 pins are there. So I cannot send byte by byte. I cannot send byte by byte. I should send it nibble by nibble. That also how means? Okay, that also how means first send the upper nibble, then send the lower nibble. First send the upper nibble, then send the lower nibble. Aditi, you got it? Why not byte by byte? Why nibble by nibble in 4-bit mode? Aditi, is it clear? Yeah, so first send the upper nibble, then send the lower nibble. So I'll just roughly write the code here. We will see the code more in clear way. So first send upper nibble. Okay, then send lower nibble. Then send lower nibble. And here what, after sending upper nibble, lower nibble. So when you first send upper nibble, enable the CLCD so that data is okay transmitted. Enable the CLCD. After that, disable the CLCD. Okay, so that you get time for okay next nibble. enable the CLCD, send upper nibble, enable the CLCD, so the data get transmitted, then disable it. Then send the lower nibble, how to send upper nibble or lower nibble we know. Okay, we have to send it using this D4 to D7 pins. D4 to D7 pins. Upper nibble we have to assign. Lower nibble. Then again enable and disable the CLCD. Already told you. Okay, what will happen? Okay, we have to use this enabling because what will happen? If you keep always CLCD enabled, garbage values will get transmitted. If you keep the CLCD always enabled, garbage values will get transmitted. Only when you want to transmit the data, enable the CLCD. When you want to transmit the data, enable the CLCD. Then now you have sent your data. What will happen? CLCD will take certain time to process it. CLCD will take certain time to process it. Correct? We have discussed this. So what we have to do is, again here we have to provide a delay. Means we have to give time for CLCD to process it. We have to use a delay function. A built-in delay function is available. I'll explain you that. Okay, we have to provide a delay, time to process that instruction. This is how we are going to send a byte of information from microcontroller to CLCD. Whenever you want to send a byte of information from microcontroller to CLCD, we'll use this function called CLCD write. Inside that CLCD write, what we are doing is first we are specifying using RS bit whether you are sending a data or instruction. You are specifying whether you are sending a data or instruction. Fine. After that, we have a byte of data, but you want to send nibble by nibble because it's a 4-bit mode. So first send the upper nibble, then send the lower nibble, then wait for certain time to till the data get processed. Wait for certain time till the data get processed. Yeah, roughly I have just written the code here. We will go through detail. Okay. So next what we are doing, using this what we will do, we'll set up. Okay, we configured the pins. We initialize the CLCD. Okay, what we did here is, I'll repeat again, same thing. We have configured the port pins. We will follow the data sheet. Following the data sheet. Yeah, configure the after that follow the data sheet of CLCD and initialize it. Initialize the CLCD. Initialize CLCD. Now what is happening here? CLCD is ready. Okay, pins configured. Initialize the CLCD is ready. These steps we are going to follow. Okay, to initialize these steps. Okay, now your CLCD is ready for to display anything. So you want to display a character, send it to it. You want to display a string, send it to the CLCD. Yeah, now I want to display A. Example, I want to display what? A. I want to display what? A. Okay, then what we have to do is we have to send that A to the CLCD. How to send? How to send anything from microcontroller to CLCD? For that, we already have a function, CLCD write. So you can send it. We have a function ready. Using that, we can send it. Now, I want to display A correct. But where? I already told you, like we are going to use CLCD in this format. What is that? We are going to use it in 16 cross 4 format. 16 cross 4. Okay, means 4 lines, 16 okay characters each we are going to display. Line 1, sorry, I'm going to index it from line 0, line 1, line 2, and line 3. Okay, line 1 of line 0, line 1, line 2, and line 3. Okay, so all the 3 lines are having one address actually. Now I want to display A, but where? You want to display A, but where? Whether on line 1 or on line 2 or on line 3 or on line 4. Which one? And yeah, if it's line 0 also, from where? Line 1 also where? So many 16 positions are there. So each position is having one address. Each position is having one address. Okay. So here the address of first line, first position is, the address of first line, first position is 0x80. 0x80. Second line, first line, second position is 0x81. Okay, 82. Like that, we are having till 15 positions. We are having till 0 to 15 positions. So now when you are planning to display A, we have to specify where you want to display also. Yes, you want to display A, but where? Which line? Okay, we have to specify address as well. We have to specify what? Address as well. Okay, so for that, we will be taking one more function called CLCD put to CH. And in this function, we are going to pass arguments as unsigned char, okay, a data what you want to display, example A, and the address where you want to display, and the address where you want to display. Okay, so if I see it here, CLCD put ch A 0x80. Okay, CLCD put ch A comma 80 means I want to print A on the first line first position. Like this, I can call this function. Okay, so when you are defining this function, what we are going to do means, okay, yeah, you have to send this details to the CLCD. You have to send this details to what? CLCD, like what you want to do. See, once your CLCD is initialized and it is ready, what you have to do is you have to, okay, okay, so what we have to do is we have to, okay, tell CLCD what you want to display, where you want to display. We have to send these details. To send these details, first we have to send is what, not, okay, whether you want to send a data or address first. Yeah, always address first, because if I send A there, where it should get displayed? Yeah, I sent A, where CLCD should display it? So first I have to specify where I want to display, then specify what I want to display. So first send address, then send data, then send data. Yeah, we know how to send anything from microcontroller to CLCD. From microcontroller to CLCD, anything you want to send, we have to use this function CLCD write. We can use this function CLCD write. Okay, so CLCD write. First send address. Yeah, I can send it like this. Address, and now address is nothing but instruction. Address is nothing but what? Instruction. So I have to specify it as a 0 because R bar W should be what? 0. So not R bar W, RS pin should be assigned with 0 for instruction. 0 for instruction. So I have to send here 0 because I send 0, that 0 will get assigned to the RS pin here. Then next you want to send data. Okay, so CLCD write, nothing but your A. A will be going here because you are going to pass A as the argument here. A or anything what you want to display. That should be sent as what? RS. This will go and get assigned RS as 1 because what you are sending is a data. What you are sending is a data. Yeah, this is what to print a character. This will print a character on the CLCD. This will print a character on a CLCD. Okay, CLCD put CH. Okay, once you configure your CLCD, you can send anything you want to display to the CLCD. So to display a character, I created a function. Here we are sending the details, what you want to print, where you want to print. I want to print A on the line number first, line number 0. So I'm specifying this. Yeah, this is to print a character. Suppose I want to print a string. Suppose I wanted to print a string. Few changes only we are supposed to do here. I'll just take it as CLCD print. I'll change this function as CLCD print. Example, and I'll pass this as what? str, string. Base address of a string. Suppose I'm going to print it like this. CLCD print hello. CLCD print hello. I want to print a hello on the line 2. Line 2's address is 0xC0. Line 2's address is 0xC0. So on the line 2, I want to print hello. So same thing. First send address, then send your data. See, you can send only byte here because CLCD write is accepting a byte. So what we will do, hello, we will split it. First H, then E, then L, then L, then O. We will send character by character. We will send character by character. And how to understand the end of the string? We know at the end of the string there is a null. Okay, at the end of the string, what do we have? We have null. Okay, so I'll take a loop while star str is not equal to null, is not equal to null. Okay, we will be sending string one by one. Str plus plus, star str plus plus. Send character by character. So what we will be doing? First H will go, then E will go, then L will go, then L will go, then O will go. When it reaches null, the loop will terminate. The loop will terminate. So here we'll send by character by character. So character by character, it will get printed. Character by character, it will get printed. So we have created here two functions. Okay, one is CLCD print, one more is CLCD put ch. You want to print a character, we'll use this function. You want to print a string, we'll use this function. This is just a rough idea like what we are going to do. However, I'll explain the code one more time. We will see it. We'll compile it and see the output. But till here things are clear. You got a rough idea what we are going to do here. Everyone, you got a rough idea, and are you clear with these two functions? What is the use of these two functions? These two functions are important for us when we are doing the project. Whenever you want to print anything on the CLCD, we will be using these two functions. You want to print a string, we'll use CLCD print. You want to print a character, we'll be using CLCD put ch. Hello everyone, am I audible? Is this clear? Did you get a rough idea? I'm not telling you understood whole code because code we have not seen. I just gave you a rough sketch what we are going to do here. This we started from here. Then I just explained each step in detail. We started from here. Then I explained each step in detail. You understood the configuring the ports. Then what we read in the data sheet. Then how to send a byte to the CLCD. Then how to display the character on the CLCD. How to display the string on the CLCD. Okay, fine. Now what you do is you have downloaded already, fine. If you have not downloaded, can you download this code, CLCD code? Can you download this CLCD code, everyone? Yeah, here is your CLCD code, download it. Let me also download with you. Yeah, you can see I am downloading. It's a 8-bit driver. Okay, you need 4-bit driver actually. But however, in template code it is there. In template code you will be having 4-bit driver. Don't go for 8-bit driver. Ignore it. Okay, in template code you are having a 4-bit driver. Go there. Template code you have 4-bit driver. Template code 4-bit driver. Yeah, in the template code, if you go to CLCD sources, you have a 4-bit driver code. You have 4-bit driver code. Everyone please download it and I'll open that in my MPLab ID. Okay, open project. Yeah, 1 minute. Here we have in the downloads. I'll just open the same, whatever I have shared with you. Okay, in the downloads, we have the template code. I have also told you. You also please go and check the template code only. Yeah, template code. In template codes, I'm having. Okay, we have here CLCD resources. In that 4-bit driver code, please you open it. See, when you're opening, this always asks you, would you like to associate the extension of C++ header objective type? Okay, just specify no. Okay, please specify no. Otherwise, your C files will open as a header files. Please specify no. Okay. Yeah. So I'll give you 1 minute of time. Once, okay, just go through this header file, clcd.h. I'll explain, but you go through it once. Yes, are you able to open this code? Whatever, okay, template code is there from there, 4-bit mode, are you able to open it? In template code, it is there. Okay, Dikshita. Hi, ma'am. What happened, Jay Surya? Dikshita, it is there in the template code. You have two codes. One is 8-bit code and the 4-bit code. Please go for 4-bit code. Why 4-bit? Already I have explained, Jay Surya. Why we are going with 4-bit mode? Because we are having this 4D shared with matrix keypad. Okay, so we have to go for 4-bit mode. Okay, reopen it again, Jay Surya. Just okay, restart your MPLAB ID. Close and open. It will okay, come back. Yes, everyone, you got the code where it is there. You found it. Yes, done. Yeah. So once you open here, I'm just opening CLCD.h file. See, whatever we are going to do this, right? Entire code we are going to, okay, divide it into three files. Okay, main.c, okay, CLCD.c and CLCD.h. Okay, in the main, we'll just call the functions required. In CLC.c and .h, we will define is all, okay, functions there only. This print, write, everything there. Okay, so in the .h, I'm just defining the macros required. You can see CL3 data port DDR as stress D, CLCD RS DDR as stress E2, CLCD enable DDR as stress C1. Then CL3 data port D, CLCD RS pin RE2, CLCD enable pin as RE1. RS as RE1, enable as RE1, RS as RE2, okay, enable DDR as C1, RS DDR as C2. Okay, then instruction mode as 0, data mode as 1, high as 1 and low as a 0. This is what we are specifying here. Okay, so we know that our ports are connecting to our pins. D0 to D7 pins are connecting to, okay, port D. So CLCD data port I have taken as RS pin connecting to RE2, enable pin connecting to RE1. Just defining those macros here. Then these are DDRs, data direction registers. Okay, you know, for instruction RS pin is 0, for data it's 1. For that I am specifying here 0 and 1. Then these are the addresses of your line. Okay, 80 is line 1 address, C0 line 2 address, 890 line 3 address, and D0 is line 4 address. So if I am specifying here line 1 of 0 means 80 plus 0, it will become 80. Okay. Suppose if I specify here line 1 of 1 means 80 plus 1. Okay, 1, 2, 3, 4 only. Yeah, 80 plus 1, it will be nothing but line 1 second position. Then the C0 is nothing but what? C0 means second line first position. 0x C1 means second line second position. Okay, then 90 plus x, then D0 plus x. Okay, 90 means third line. Okay, fourth line 0x D0. 90 plus 1 0x 91. This will be nothing but 0x D1. Third line first position, third line second position, fourth line first position, fourth line second position, till where? Till 15 positions are possible here. Till 15 positions are possible. So these are nothing but the addresses of your CLCD lines. This is addresses of your CLCD lines. So you can pass here on what index you want to print. If you want to pass first print on a first index, pass 0. If you want to print on second index, pass 1. Like that, you can pass here what in the place of x. X can range from 0 to 15. X can range from 0 to 15. It's nothing but the indexing. Then these are nothing but your instructions. We know we have to 3 4-bit mode 2. This function set 28 clear display 01 display on cursor of 0C. In the data sheet we have seen this. Here function set 2A. Okay, then clear display 01. Okay, display on 0C. That I'm specifying. I'm defining them as a macros. 28 01 0C. 4-bit mode. Okay, 5 cross 8. 5 cross 8 is a font size that I'm specifying here. Fine. So these are just my macros. We will use them in our functions. So going back to the main. Yeah. In the main, what we are doing is first we are initializing the CLCD, init CLCD. So in the initialization, what we are doing, as we discussed, first we'll configure the port pins. Init CLCD, making port D as output first here. There's nothing but we are configuring port D as output. Port D as output, how to configure? Using trisd. For trisd, we have defined the macro, right? CL3 data port DDR. CL3 data port DDR is here. trisd. Yeah, output, then RS pin and enable pin also as output. Then initializing the display of controller. Okay, what is this? Is nothing but from the flowchart. Okay, flowchart, what is telling? Once you turn on, wait for 30 milliseconds. See, this underscore delay milliseconds is a built-in function. This will provide a delay of 30 milliseconds. If you pass here microseconds, you'll delay provide in microseconds. This is in milliseconds. We are waiting for milliseconds. Then send 3, then send again 3, again send 3. This is our startup sequence. Send 3, send 3, send 3, wait for 4.1 milliseconds. Send 3, wait for 100 microseconds. Again send 3. That's what is happening here. 3, wait for 4.1 milliseconds. 3, 100 microseconds. 4.1 milliseconds is equal to 4100 microseconds. Then again send 3. Then send 2 here. 4-bit mode is 2. Send 2. Then function set, clear display, display on and cursor off. 3, 2, function set. These things we are sending one by one. That's what we have discussed here. Send 3, 3, 3, function set, display on, clear display. To send that, what we are using here function? CLCD write. You can see CLCD write. We are passing here. Okay, we are passing here 3 as instruction mode, which is nothing but 0. CLCD write. 8-bit mode means 3. Okay, 0. So CLCD write is a function to send it. Okay, send 3, send 3, send 3, 4. 2. Then function set, then clear display and display on. Yeah, Shrikant, this one. Shrikant is asking, why are you using this XTL frequency? See, this is the operating frequency of a microcontroller. How much? 20 megahertz. We discussed this, remember? 20 megahertz is the operating frequency of your microcontroller. When we are selecting the board, we selected this. When we are selecting the board, we are selecting this 20 megahertz. 20 megahertz, we are selecting this 20 megahertz as the operating frequency. So this will, okay, this we have to define when we are, okay, using this built-in functions. Built-in delay functions we are using, right? For this delay functions, we have to specify the operating frequency of your controller. When you are using this built-in delay functions, right? Yeah, this will provide us a delay in what? Milliseconds. This will provide a delay in microseconds. Using this, you can provide a delay. So, okay, milliseconds delay, microseconds delay. These two functions, when we are using these functions, we have to define that XTAL frequency. Okay, what is the frequency you have chosen for your board? We have to specify that. When we are choosing the board, we have specified the operating frequency as 20 megahertz. That I'm specifying there. Okay. Okay, Jaishwarya is asking if I increase that delay or decrease that delay, will the function, will the instruction be sent or not? If you increase the delay, no issue. If you decrease the delay, what will happen? I told you about the delays. It needs certain time to process it. If you are not providing that time, means your code will not work. You are not providing enough time to your CLCD to process it, your code will not work. So we can give more delay, but don't give less delay. Whatever is specified in the data sheet, we have to provide that delay. More delay is fine. Okay, it will get enough time. If you don't provide if you provide a less delay, CLCD will not get enough time to process it. So what will happen? Your code will not work. Is this clear, Jayasuriya? Jayasuriya is asking, ma'am, whatever it is specified here, if you increase this delay or decrease this delay, what will happen? He's asking. Increase will be not a problem, but not too much also. Otherwise, you have to wait for a long time. Okay. Decrease, what will happen? Okay, your code will not work because you are not giving enough time for your CLCD. Yeah, so we are just following this data sheet and sending the instructions as specified in the data sheet. Okay, we are sending the instructions as specified in the data sheet. These all are instructions only. You can see I'm passing here instruction mode, instruction mode, instruction mode, instruction mode, instruction mode. Okay, we are sending all these as instructions because it is specified here in data sheet as well. RS pin is 0 means all are instructions. All are instructions. Yeah. Then coming back and see a CLCD write function. Okay. So what we are doing, you can remove this, not required. It's nothing a typecasting. You're typecasting that mode to a bit. Okay, so CLCD write function, we are passing here a byte and the mode. Okay, byte means what you're trying to pass. Mode means whether you're trying to send a data or a instruction. Yeah. So what we are going to specify here, we are going to pass here a byte and a mode. Okay, whatever, it can be instruction or data mode. So how we are, first we are assigning to the RS whatever mode is there. Then send data means, okay, we have to fetch a byte and assign it to the port. Okay, we have discussed here. Send nibble by nibble. Okay, so we have to assign it to the port D. Okay. Yeah. So nibble by nibble. Example, my data is 0x. Okay. AA is my data. So I have to fetch the upper nibble first, then fetch the lower nibble, then send it. So how to fetch the upper nibble? Just AND it with 0x, 0x, F0. You'll get the upper nibble and shift it by 4 times. And we have to send it to the D0, D4 to D7 pins. Yeah, not shifting by 4 times, just assign it. Okay, so port D equal to fetch the upper nibble. Only upper nibble we can assign like this. Then fetch the lower nibble. D0 to D7 pins belong to port D, right? Then port D. Okay, lower nibble. Just 0x AA. Then AND with 0x 0f upper nibble. Lower nibble, sorry. 0f. Then, okay. Shifted by 4 times. Shifted by 4 times. Fetch the upper nibble, then assign it. Shift it and assign it. Then fetch the lower nibble, then assign it. Okay, fetch the upper, first fetch the lower nibble, then fetch the upper nibble, then assign it. Like this we are going to work. Yeah, fetching the upper nibble, assigning it, enable the CLCD, then fetch the lower nibble, then assign it to the port D, then enable the CLCD. After that, we are providing certain time to get it assigned and a delay to get it processed. See, this delay is from data sheet. Okay, from the flow chart. This delay is from flow chart. This delay is whatever you send, it needs certain time to process it, so we are giving it. This is the maximum delay in the data sheet, that only I am giving here. Yeah, CLCD write function. Then using CLCD write, we are going defining the CLCD put ch. Put ch, first sending the address, then sending the data. Sending the address as instruction mode, sending the data as data mode. Then say the CLCD print function. What we are doing here, we are first sending the address as instruction mode, then sending the character by character of the string in the data mode. This we have discussed. Coming back to the main, we have initialized the CLCD. Once we have initialized the CLCD, you can display anything on the CLCD. So to display, we are using a function CLCD put ch or CLCD print. You want to display a character, we will use CLCD put ch function. You want to display a print, you want to display a string, you can use CLCD print. Okay. So first I am printing what? Okay, see, when it comes to numbers, you cannot print them directly. So we have to convert them into ASCII. So you can see here, if I want to print a 5 plus 0, I'm making it as ASCII. You cannot print directly numbers on the CLCD. We have to make them as ASCII characters. In the beginning, I have specified, okay, what you can print on the CLCD are only ASCII characters. What you can print on the CLCD is only the ASCII characters. Display ASCII characters. So you cannot print numbers directly. We have to convert that, okay, integers into ASCII. So in order to convert integer into ASCII, we have to add a ASCII 0. 5 plus ASCII 0 will make it as ASCII 5. Will make it as what? ASCII 5. We'll make it as ASCII 5. Then here I am trying to print this. I am trying to print 5 on the line 1 fourth position. This I am trying to print hello on the line 2 fourth position. Then I am trying to print 4 on the line 3 fourth position. Then word on the line 4 fourth position. You can see line 4 of 4, line 3 of 4. Here we can specify the index. These are nothing but the addresses where you want to print. Okay, I want to print on line 1, line 2, line 3, line 4. I can specify here, and we can specify the indexes. So you can download this code. You can change here, change your name. If you already have downloaded this code, you can print your name also on the CLCD. You can print your names also on the CLCD. You can print names also on the CLCD. Just remember, you want to print a single character, use put ch function. CLCD put ch. You want to print, okay, a string, then use CLCD print function. Then use CLCD print function. Is this clear, everyone? Are you clear with this functions, how to print, okay, anything on the CLCD? How to print anything on the CLCD? Are you clear? These two functions are important, CLCD put ch and CLCD print. We are going to use them in our project. You want to print a character, we'll use CLCD put ch. You want to print a string, we'll use CLCD print. Okay, let me clean and build. Okay, and see the output. Okay, build is successful. Go to your board, open your board, pick sim lab. Yeah, I'll just change the CLCD to 16 cross 4. 16 cross 4. Then file, load X file. I have my template codes in the downloads. I'll go to downloads. In the downloads, I have this template codes. In the template code, I have a folder called CLCD sources. There, 4-bit driver code. In that dist, default, production, and here goes my X file. You can see, okay, I'm trying to print on the line 1 from the fifth position. You can see 0, 1, 2, 3, 5th, it is getting printed. Then hello, line 2, then 4 on the line 3, word on the line 4. Okay, can you also try this code and tell me whether you're getting this output or not? You need not do much here, just download the code from the LMS, clean and build. If you want to try, you try printing your name, remove hello, put your name there. Okay, remove hello, put your name there, it will work. Can you try? I'll give 1 minute of time, download the code, compile it, upload and check. Yeah, so are you able to do this? So the code is there, Arya. Arya, you are not able to get the code in the LMS, Arya. Code is there in the LMS. Okay, someone wanted me to display Happy New Year. Okay, let us do it. Yeah, let us display Happy New Year. Okay. Happy New So you can say I'm always putting it in double quotes. New Year 2026. We'll try to change the indexes as well so that I can show you. Okay, this I'll start from 0th index. Okay, this I'll start from 5th index. This I will put it at 8th index. Okay, this I will put it at 12th index. Fine. Line 1 of 0, line 2 of 5, line 2 of 3, line 2 of 4. Happy New Year I'm trying to print. Clean and build. Okay, we'll upload this. Reload last. Happy New Year did not come. Okay, one mistake I made. Can you tell me what is the mistake I made? I am trying to print a string using put ch. I am trying to print a string using put ch. That is not possible. I have to use print only. I have to use here print only. Whenever I want to print a string, I have to use print only, not put ch. Yeah. Akash, you can watch recorded session. Okay, it is available in LMS, Akash. No problem, Shrikant. Others? Yeah, you have any questions, any queries? Anyone able to display your name or using this code? Anyone tried? Let me know. Anyone tried displaying your name? Ganga, Gagan. How to explain Coda? Dharani, we are at the end of the things. We are still asking how to upload the code. See, whenever you want to upload the code, go to File, Load X File. You open your project. Okay, wherever your project is there. My project is in Downloads. Okay, here I have my 8-bit code driver code. Go to the project, go to the dist, then default, then production, then the X file. Go to your, yeah, Jayasuri able to do it. Good. Shrikant is asking, can you create smile or emojis? You can do it. Okay, you try it. I'll be not covering that here. But limited, not more. More emojis not possible here. It's having limitation because it is a CLCD, not GLCD. Some symbols are possible, not all. Dharani, you did not upload any code till now. Your LED code, nothing. Akash, you are not able to log into LMS. You please mail to the support team. You please mail it to the support team. I don't have. I cannot help anything with that. You please mail it to the support team. Yeah, Dharani, if you're not able to attend the classes, recorded sessions are there. Please watch and complete the previous things. Okay, fine, everyone. So till here we are done with the CLCD. Till here we are done with the CLCD. Yeah. So we'll stop here for today. Tomorrow we'll start implementing the project. So don't miss tomorrow's class. No, tomorrow you don't have class, Saturday. Yeah, tomorrow you don't have class. Yeah, tomorrow you don't have class. Okay, we'll again meet on Monday. From Monday we will start implementing the project. From Monday we'll start implementing the project. Okay. Yes. Thank you, everyone. Okay. Good night and happy New Year again. We'll meet again on Monday. Till then, please practice your all other codes, and you'll be having test again tomorrow. Please do attend the test. Thank you. Good night, everyone. Any queries, any questions, please post it on a discussion forum. Any questions, any queries, please post it on a discussion forum.